Hello everyone. Hello everyone. रिपीट का व्हायला लागले रिपीट का व्हायला लागले
1, 2, 3. I've been running from the pain, trying not to feel the same, but it's a shame that we miss again. See, my confidence is shaking and my heart is feeling vacant, so you try to fill it in. You said I could fix the broken in your heart. You would say then, darling, but I don't know why you're shooting in the dark. I can't feel in nothing. Pray for me. I never had somebody, so I don't know how to love. Pray for me. I need somebody, so I can learn how to love. I know it. How to love. I know it's been a while, 'cause my memory's on trial for the way I used to be. My head is running miles, round in circles, and I try to find a lead to light in me. You said I could fix the broken
Yes. How are you? Good. Good afternoon. Can you hear me? Okay. Okay, fine, fine. Thank you. Yeah, sure, sure. Okay. Sir, it is not activated that share my screen. Hello? Oh, okay, 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 okay. Yeah, yes, yes, I got it now. Got it. Can you see the first slide? Hello, Amit? You there, Amit? What exactly the schedule, like who will speak first and how we should proceed? Yeah. Okay, fine, fine.
Hello, sir. Am I audible? Audible? Okay. We will wait for 3 more minutes and then we will start.
Okay, fine. Okay, fine.
Sorry, sir. start the recording, huh? Okay, okay. Sorry, sir. Yes, we will start now. Okay. Hello, dear participants. Good afternoon to one and all present here. On behalf of AISSMS Institute of Information Technology, I am Dr. Meenakshi Thalor, Head of IT Department. Welcome you all, the participants and panelists. I express my sincere gratitude towards the AISSMS Society and Dr. P.B. Mane, Principal of AISSMS IYT, for his continuous support and encouragement. AISSMS Society is committed towards imparting the quality education to the society. So, in that line, we have taken this initiative to conduct a full-day workshop on C++ for students. And I can see that there are many participants who have joined us from the different regions of Maharashtra. Once again, welcome you all. And with this, I hand over the charge to the Vakhare sir, who is the coordinator of this workshop. Vakhare sir.
Hello, good afternoon all. Hello.
Yes, sir, you are audible.
Hello. So today below here Samadar sir. Sir has 20 plus teaching as well as industry corporate experience. I would like to hand over session. Sir, please start our today's session.
Okay, thank you so much, Prashant. Thank you, ma'am. Thank you, sir. Let's begin with our workshop. So today's agenda is what is object-oriented programming. Since C++ is object
Jamadar sir? Prashant sir?
Shall I continue or shall I give a stop, pause?
Sir, now you are audible. Actually, you are on mute. That's okay, no problem, sir. Please share your screen, sir.
Uh-huh. Is it okay now? Amit sir, is it okay?
Yes, sir. It's okay now. You can start, sir.
Okay. Am I audible properly to everyone? Check that.
Yes, sir. You are clearly audible to everyone, and your screen is visible. Please
Okay,
start.
fine. So the characteristic of procedure oriented is how to solve. The focus is on solving the problem how. But this will lead to complexity when we develop complex softwares. So we went for object oriented programming. In 1980s, John Stroudstrup developed C++ language. So C was that time very popular. So he thought when C is so powerful, if we add features of object oriented programming to it, it will be more powerful. And that's how it happened. So the C++ became one of the powerful language with object oriented programming features. So what are the advantages of adopting object oriented programming? Here the focus is on object that will provide easier solutions to complex problems. With procedure oriented, what happens? The solution was available, but the solution was quite complex, tedious. Now we can develop simple solutions for complex problems with object oriented programming concept. So that's why object oriented programming languages are one of the best choice for software development. So let us see what are the advantages of object oriented programming. You can remember in simple way 3 E's. E for elephant. 3 E's you can remember. Easy development is possible with object oriented programming. Easy maintenance of the software is possible, and similarly easy upgradation of the software is possible. And these are the three crucial things for development as well as for the system. So easy development, it will help the programmer. Maintenance and upgradation, it will help the system, or it will help the company which wants to develop software or which wants software for some system. So what are the features of object oriented programming? So the features are data abstraction, data encapsulation, classes and objects, inheritance, polymorphism. These are the 5 core features of object-oriented programming. Without this, you cannot just say that a language is object-oriented programming, which it supports object-oriented programming. These are the 5 pillars. So let us see one by one what exactly these are. Data abstraction we'll see. Data abstraction is a process of describing an object with essential aspects without going into details of it. Like if you want to describe an object, what is essential, you will only focus on that. What is required, you will focus only on that. As such, the object is associated with various other facts. We will not go into that because we are not interested in it. For example, look at this car example. Here I have shown you 4 cars. The first car is the simplest car, where you will see only wheels and body. Then the next car is one where you will see windows also. Then the other more details. The last one has all the details. See, now as a user, if you want to show what is a car, how the car is to a kid, you will choose as per the requirement. If the kid is very small, the first figure is enough for him. So he is somewhat like elder, grown up. Then you can show him the last car. He can understand that. So as per the requirement of the user, we'll provide the things. So that is what data abstraction, focusing on only the essential aspects without going into the background details. The other example I can say, so if I want to take your introduction, come on, please give your introduction. You will say, I'm so and so, I'm from so and so college, and I'm from so and so place. You will not go into the details where you are, which is your native place, where you completed your education. Rest of the things are not important for me. For me, your name, for your college, from where you are coming, that is important. So this is how, what you need, what the user needs, only you should provide that in the application. So this is, with the concept of data abstraction, it is possible to provide only that thing which the user wants. Pinpointedly, you as a programmer have to find out what the user needs. The user may not be knowing what exactly he needs. You have to understand and you have to provide, and this is possible with the concept data abstraction. In future, when we discuss classes and objects, there I'll show you how we make it simpler. So by the number of attributes, more complex, less attributes, less complex. So the first car has less attributes, whereas the last car has more attributes, more things. So this is how we can say the first car is over abstracted. So we have reduced a lot of things. We have made it very simple. With over abstraction, what happens? It will become very, very simple. And with under abstraction, it will become more complex. More details will be added. So this is how under abstraction and over abstraction, you have to be in between exactly what the user needs. I hope you got it. What is data abstraction? Now let's take the next concept, data encapsulation. So we have seen with the data abstraction what we achieve. We provide simplicities to the application. The program or the application will become simple for use. So it is because of data abstraction. You have not added unnecessary things and made the system complex. Data encapsulation is the next feature which provides data protection. You know, if anything, something is very important for you, you will not keep it open. You will cover it. You will hide it. That's what we are doing here. Data is very important for us. And that data we protect with the concept of data encapsulation. We provide a block in which the data is available. Outside the block, that data is not made available. So this is encapsulation. So when the data is available in that particular block, we'll keep the methods which handle that data in that block itself. So this is how we bind or wrap methods and the data that is processed by those methods. Through this, we'll be able to hide non-trivial data, like important and crucial data we hide and we protect it. So this is another important concept. This is also implemented with the help of classes and objects. So class will help you to implement data abstraction and data encapsulation. That's why they are a head and tail of a coin. Without the other, we cannot implement the other one. Like without data abstraction, data encapsulation is not possible. Without data encapsulation, data abstraction is not possible. Both must be there. Then only we can achieve this. Both the concepts are like mutually dependent. So now let's take the concept of classes and objects. As you know, generally, what is a class? Class is a collection of objects exhibiting similar characteristics. So what is the meaning of similar characteristics? They have similar kind of attributes. What the attributes are? For example, if you take a bird is a class. So what are its attributes? The altitude of flying, their beak color, their leg color, their feather color, the type of bird. These are all attributes. When we have values for these objects, they are called as states. States of an object. When we have states for the objects, attributes, and they are giving same behavior, similar behavior. Now bird is there. We are talking about feather color. Okay, feather different colors are there. Parrot is green, sparrow is brown, crow is black. This way we have different colors. But the feathers purpose, they exhibit a similar behavior. What is that? Flying. So they belongs to the class of birds. Feather. Similarly, beak is there. Beak color. So all birds have a beak. All birds have a legs. So this they have similar characteristic. That's why if any you describe one object, say there is a XYZ object. So can you name it? Then you describe the object. The object has a beak. The object has a feather. The object has a legs. Then I will guess, yeah, it has to be some bird. So you will categorize it to the class of birds because of those attributes and states. So this is a class is one which exhibits similar characteristics. When you want objects of some similar characteristics, you can define a class and you can create objects for that. So in programming context, when you define a class, it is some template kind of thing or a blueprint kind of thing. You can see in figure. Look at the figure. So there is a class car where you will be describing what kind of object you want. What kind of object you want, you will be describing. Say you are describing it's a class vehicle. Then you will be describing number of wheels. How many wheels? 4, 6, 12, like that. Then the brake system you are describing. The steering system you are describing. The engine type CC you are describing. So what kind, when you provide a particular description and when you create object, so all objects have a similar behavior, but different states. Similar behavior, different states. Say for class pencil, there are 3 pencils. They all are called pencils because they are used to write. One is a red, which exhibits a different behavior. Red, it writes red. The other writes blue. The other writes green. But they are all called pencils because they have a behavior of writing. Though they have a different states. The states are like blue, red, green. But they are objects. Why? They write. Similarly, this is a class car. Here we have different objects. Polo, Mini. So these cars have been created from the class structure. That is a template. What kind of class? That we'll discuss in detail when we go for programming classes and objects. In this theory, this is enough, I guess. Class and objects. So a class has 3 characteristics and objects has corresponding 3 characteristics. So what are the 3 characteristics of a class? Class has a unique name. Class has attributes and methods. We don't have 2 classes for similar objects. We have a unique class name. For example, birds. Any object which flies in the sky, which has a beak, which has a feathers, which has a legs, we say that it belongs to the class bird. So bird is a unique name. There is no any ambiguity with any other class. And what I said, beak color, feather dimensions, these are all attributes of that class. Methods, you can say flying, to what is the depth, height, altitude of flying. Flying is a one function. Method, in object oriented programming language, method means what? It is a function kind of thing which determines behavior of an object. So by modifying the states of an object, you can modify the behavior. The states of an object, how you modify? Through function of a class, you modify that. That's how the object's behavior is changed. For instance, class bird, flying is one method. So for sparrow, I have set the altitude as 100 meters high. It flies 100 meters high from ground. Then through this method only, I change the altitude. I'll make it 1,000 meters. Now that bird, that object which was flying 100 meters earlier, now because I changed the behavior, so it started flying for an altitude of 1,000 meters. So the sparrow has changed its behavior now. How it has changed its behavior? By function, by the method, by changing the altitude through method, I change the behavior of an object. So this is how the three are linked with object. The unique name of the class provides identity to an object, and the attributes provide states, and the methods will control behavior of an object. Here you can see one more example. Account. Account is a unique class name. Account number, balance, type are its attributes. Whereas show balance, deposit and withdraw are its methods. So through methods, like say the method is deposit. Through deposit, you will add value. So the account's behavior is changed. The account's states are changed. When account's states are changed, the behavior is changed. So withdraw, when you remove some money, withdraw some money from your account, the balance is changed now, the state is changed. So this is how through methods you will control behavior of an object. Through methods you will change states of an object. By changing states you will be controlling the behavior. That is what important for us. How we control behavior of an object. By controlling the behavior, we get the desired output. So I guess the class concept is clear, object concept is clear. One more point here is that there are two different types of objects, tangible objects and intangible. Tangible, which we can touch and feel, whereas intangible, which we cannot touch and feel. For instance, university is there. University is one object. So can we touch that? No, it's just conceptual. That sort of objects are intangible objects. So the next concept is inheritance. So what is inheritance? The literal meaning inheritance, you have studied in school biology. Inheriting the properties of our parents. What characteristics our parents we have. Normally, sometimes we do have the same characteristics. Then we say that we have inherited it from my father, my mother, like that. So inheriting, that's the same concept we have here, same meaning. Creating or defining a new class from existing or old class is called inheritance. So why we should incorporate inheritance and when to incorporate inheritance? These are the two questions. Can you guess why inheritance concept, how the inheritance concept is helpful in software development? Just guess what would be the idea behind inheritance. See, you can just realize at your home, your grandfather or grandmother, what they do, if anything is in scrap, they don't allow you to throw it. They say, don't throw it, I'll make use of it for some purpose. Have you heard this kind of thing? Yes, this is what inheritance. Making use of old things for something new. So by doing so, what your grandfather or mother they're achieving, what they actually at the bottom line, what they are achieving, they are cutting down the cost of something. They are saving some money. They have created something new from the old, and that way they are not spending money for the new ones because they created from the old and they added some new things. So they are cutting the cost. So the same thing these software companies want. They want to cut the cost of software development. And this is the point where inheritance helps. Inheritance basically implemented to reuse the existing code. So the concept is reusability of code. to reuse existing code, we use inheritance, or you can say through inheritance, we will be able to reuse the existing code. So by reusing the existing code, what you will achieve at the bottom line, it is you will be saving the cost of development. So when you are reusing something, you are saving the cost of development. That's what the companies want. And if you as a programmer cleverly inherit things and save the cost of development, it will be the credit for you. So when to use, you cannot use blindly inheritance. So if anything is good, we cannot use it blindly everywhere. Where it is suited, there only it should be used. Where you have to use, you have to check. So this is the existing class, this is the old class I have, and I want a new class of this. I want a new object of this. Already there is an object called employee with me. I am planning to create a new object called manager. Then I have to check manager again what the employee has the details, or what the employee object has functionality. The same functionality the manager should also have, because manager is an employee. So this is the rule. If manager is an employee, is a relationship is holding here between the existing class and new class. The new class is manager, the old class is employee. So what's the relationship between these two? The relationship between these two is a, or kind of. Manager is a kind of an employee. Manager is an employee. So this way, wherever is a relationship. Now if you want to design a new object called supervisor of in a company, then this object altogether new, you need not design. You have an existing class employee with you, so from that you can create it, because supervise is also an employee. Supervise is a kind of employee, so there it holds good. Where this inheritance cannot be used, one example we'll see. Say there is already a class called engine with me, vehicle engine. Engine is there with me. So I am designing a new class called car. Can you tell me now, can I use inheritance over here? There is engine and I want to design a class called car. Car is an engine. This is one statement to check. Car is a kind of engine. And there is one more relationship. Car has an engine. Car has an engine, which is true, which is most true. Car is an engine, or car has an engine. Which is most true? Obviously, the most true is car has an engine. So there doesn't hold good either relationship. So then you should not derive, or you should not create a new class called car from engine. The inheritance cannot be used over here. So it is called as a composition. We have a has a relationship. So where has a relationship is there you should not use inheritance. Where purely is a or kind of relationship, properly is a or kind of relationship holds good, there you have to use inheritance. And there are different types of inheritance in different languages. In C++, we have single level inheritance, multiple level inheritance, multi-level inheritance, hierarchical inheritance, and even hybrid inheritance. Whereas in Java is also object-oriented programming language. There we don't find place for multiple inheritance. There we have single level, multi-level, hierarchical, only three types. There is no multi-level, there is no multiple and hybrid inheritance. I hope this is clear for inheritance. When we actually see classes and objects and inheritance, there again I'll discuss in detail. the concept of polymorphism, also runtime polymorphism, I will discuss over there. Next, we'll see what is polymorphism. Just read on your screen what is polymorphism. Polymorphism is an important feature of object-oriented programming paradigm. It's a very, very important feature as it will help you to upgrade, easy upgradation and easily extensible. Extensibility of software is possible. How it is done, I'll demonstrate you when we discuss inheritance and polymorphism in our subsequent sessions. Polymorphism can be implemented at compile time and runtime of the program. Poly means, poly, many forms. One object exhibiting many behaviors, different behaviors. It appears that there is only one object, but in different contexts, it will give different behaviors. So that is possible with compile time and runtime binding. If you link the function with call at compile time, it is compile time binding or static polymorphism we call. In C++, how static polymorphism is implemented? In C++, static polymorphism is implemented with the help of function overloading and operator overloading. Whereas the dynamic polymorphism or runtime polymorphism is implemented using virtual functions. When we discuss inheritance in subsequent sessions, I'll discuss runtime polymorphism taking the help of virtual functions. So what is the objective of polymorphism? The objective of polymorphism is to make an object behave differently in different contexts. So what we achieve through this, we achieve easy upgradation of the software, easy extensibility of software is possible. Just look at this image on your screen and think for a while. I'll be back in few seconds. Like a customer, and if you're in traveling somewhere, you behave like a passenger. At school, college, you behave like a student. So you are one object only. When the context provided to you, some context, as per that you behave. That is what the concept polymorphism. If I provide a new context to you, like the context is say army, armed forces, then you will behave like a soldier. So this is how easy upgradation, because of polymorphism, when a new context is added, easily it will adapt to the new context and behave as per the new context. So I'll demonstrate the concept of polymorphism when we discuss programming in C++. So now let's see the language aspects. We'll spend more time here. If you have any doubt, any thing, you can just send it to Amit sir, Prashant sir. They'll let me know. Amit sir, can you hear me? Amit sir, you there?
Yes, sir.
If you are you getting comments kind of thing, like students are able to understand and they are audible? Am I audible to all of them?
Yes, yes, sir. You are audible, sir.
Okay, if any queries are from their side, let me know.
We'll do it later on, sir. Once we
Okay.
at the time
Shall
we'll
we
have.
continue now?
Yes, sir.
Okay, fine. So you, in a nutshell, you have seen the object-oriented features are data abstraction, data encapsulation, classes and objects, inheritance and polymorphism. Data abstraction basically focusing on essential aspects, and it helps to provide simplicity to the system or software. You will be able to develop simple softwares. And data encapsulation, it is what binding the data and methods together, and it will help you to protect the data. Since you encapsulate, as a result, the data will become the data will become invisible, and this is how information or data hiding is achieved. And classes and objects, these are the concepts using which we implement data abstraction and data encapsulation. And class, it has three characteristics: unique name, attributes and methods. And object has three characteristics corresponding to these three. Because of the class name, the object will get an identity. Because of the attributes, objects will get states, and through methods of a class, we control behavior of an object. And inheritance, it is designing or defining a new class from existing class. What we achieve through this, we achieve code reusability, and hence we save the cost of development. And polymorphism, one name, many forms. We make an object to behave differently in different contexts. This concept helps us to extend easy upgradation and easy extensibility of the software. So this is what the summary of object-oriented programming. And the the advantages I told you: easy development, easy upgradation, easy maintenance of the software. So because of these three advantages, object-oriented programming languages are popular in software development industry. So the one of the basic object-oriented programming language is C++. C++ language was developed by John Stroudstrup somewhere in 1980s. Actually, initially it was called C with classes. Then they had not given any name like C++. Earlier they were calling it as C with classes. It is a C language only, just they had added the object-oriented programming features from already existing object-oriented programming languages like Smalltalk, and these were already existing. Those object-oriented programming language features they added to C. They were not as powerful as C is. That's why when John Stroudstrup realized that C is so powerful, if we add language object-oriented features to it, it would become a language of choice for everyone for software development. With this intention, he added object-oriented programming features to C. So he called C with classes. But later they realized that since it is a incremented version of C, why not we should use an increment operator of C? They added the operator plus plus, and it became a C++ language. Actually, what we are using, it is a C++, standard C++. We'll see one by one, like what are how many keywords are there and everything. So that comes under language aspects. Variables, constants, and keywords. You know, every language, when we talk about any programming language, it has variables, constants, and keywords. So what variables are? If you know C, you are familiar with these things. Anyway, once we'll brush up. A variable is a quantity which does change its value during program execution. For instance, price of an item, height of a student, name of a student. So this way we can have different variables. There are variable naming conventions in programming languages. We must follow them. It should not start with any number or any special symbol other than underscore. it should not be a keyword, there should not be any space. So such conventions and rules we have to follow and frame a variable for storing values, which can change during program execution. Whereas constant, it's again identifier. These are the quantities which does not change during program execution. If you declare something as a constant, if you say this is a constant, then during programming, you cannot change the value of it. For instance, pi, if you declare pi as a constant, then you cannot change the value because you have declared it as a constant. Whenever you try to modify the constant or try to change value of a constant, the compiler flags an error. And for your information, the name of the error is called L value required, because you are trying to modify, it needs a L value. There are, whenever we talk about variables constants, we have two values, L value and R value, left side value, right side value. So left side, right side of what? Left and right side of assignment operator, equal. A equal to phi. When I say equal to phi, A is L value and phi is a R value. So constants are always R values. They cannot become L values. So when you try to modify a constant, you are using constant as a L value. So it says it is not a L value. L value is required. Whenever you try to modify a constant, what error you get? It is the L value required error. So remember it. In future, we may come across this thing again and again. And finally, keywords. Language has some keywords. Those keywords are reserved words. They cannot be used for any other purpose other than the defined purpose. For instance, the data types, int, float, char, double, bool. These are the data types in C++, and they are keywords also. If, else, while, for, these are all keywords. C has 32 keywords. Standard C has a 32 keywords. Similarly, standard C++ has 63 keywords. C++ is a superset of C. You know, whatever every correct instruction of C is a C++ instruction. Why? Because C++ is a superset, or C is a subset of C++. All valid C instructions are part of C++. So C, all 32 keywords of C belongs to C++. So C++ has its own 31 keywords only. 31 plus C is 32. Total it is 63 keywords we have. So we'll see in future this list also. Now for timing, it is enough. Variable, constants and keywords. And data types, we have primarily 5 data types: int, float, char, double and bool. You are familiar with int, float, char and double. They are used, you have used in C also, or if you have done Python, there also you'll be using int, integer it is. And for whole numbers, float and double for real numbers, char for character data type, bool for Boolean values like logical values, true or false, A greater than B, true or false. Such results now in C++ we use bool data type. In C, such logical values we represent with 0 and 1. So true, logical true, non-zero is treated as true in C, and 0 is treated as false, logical false. But here you can represent with a new data type called bool if you want. So these are the 5 basic data types in C++. Then we'll see C++ instructions. C++ has a different kind of instructions type: declarative instructions, input instructions, processing, output and control flow instructions. In language aspects, all these things we'll see one by one. And then what is a reference variable? C++ functions. So let's start with variable, constants and keywords, and we'll see one example of it. So here in the previous slide you have seen C++ instructions, type declarative instruction. After that we have input instruction, input output. The first category is a type declarative instructions. Type declarative instructions are those which are used to declare the type of a variable or constant. So when you declare what kind of variable I am using data type int, float, double, character, boolean, you use these data types to declare a variable or constant. This kind of instruction is called as type declarative instructions. You can see here, so this is a double price. So this is a type declarative instructions. And similarly here, int a comma b, it's a type declarative, float c. With respect to type declarative instruction, we have one aspect in C++. The characteristic of C++ declarative statement is that they can appear anywhere in the program. You know, if you are a C programmer, if you have studied C, in C there is a constraint. There is a constraint that all type declarative instruction must appear at the beginning. They must be first instructions. If you use any other instruction and then if you declare again a variable, then it is not allowed in C. But in C++, anywhere you can declare a variable. And even you can declare a variable in loop also. For I equal to 0, I less than n, I plus plus, when you say, you are supposed to declare I. Then for int I equal to 0. This way you can start. So you can declare anywhere the variable in C++. That is the point you have to remember. The second category is input instructions, input output we'll see. In C language, you know what is the function used for printing printf. What is the instruction used for reading scanf? You know how complex the scanf statement is. You need to use conversion specifier and addresses. Here it's not that complex. And one more thing I would like to pinpoint here. C is a procedure-oriented programming language and C++ is object-oriented programming language. So you are doing one task, you are printing value, you are printing some message. It is a task. If you are using C, you will be focusing on how. That is, you are using a function for it. You are using a function printf. And you are using to read something scanf function. It is both are functions. So the function means it is what? Procedure. Basically a function is what? Set of instructions. It is a procedure. So procedure oriented. Now how that printing and reading task is done in C++? Since C++ is a object oriented, here everything is done object oriented. Object is there. For every task we have a object behind it. Now how, see, you are reading some value, then you will be using an object here called scene. Scene is an object using which you will read. Cin and extraction operator. Two greater than symbols make an extraction operator which is used to read value of a variable using scene object. So it is not a function, it's a object. Using object you are reading. That's how C++ is a object oriented programming. We don't use function here. We are using object. Scene, say for example double price, scene price, int a comma b. You can read a single variable, multiple variables also you can read. ABC, multiple variables of different types you can read. Whereas in C, if you want to read, you need to provide all conversion specifiers like %d, %d, %f, then address of A, comma address of B, comma address of C. This way it's quite complex. But here in C++, it is very simple statement like scene A, B, C, like this. We'll see one example of this. After output statement, we'll see. Again, the printing task we do with the help of operator and object. Again, it is a object, not function. In C, you use printf function. So since C is a procedure oriented, you will be using a function, and here C++ is object oriented, you will be using cout object. C in, cout, these are objects of iStream and OStream class respectively. C in stands for console input, cout stands for console output. Since you are reading from the console device, you use this object. If you are displaying on console device, like screen is a console device, keyboard is a console device. So you are reading from keyboard, so scene. You are displaying on screen, so it is cout. This is a console in, console output object of. These are objects of iStream and OStream class. So it is object oriented. We are using objects. You can print a text using cout. You can also print value of a variable using this object. You can look here how I have done it. Just have a glance. Now we'll see one example of the simple example we'll see. I'm using MS-DOS for simplicity, and most of the basic concepts, basic functioning of the language can be best understood through Turbo C compiler. Most of the truths are based on Turbo C compiler. Later on, using GNU Linux, also you can use, or any Windows-based platform you can use. They work more or less the same way. But the basic understanding, fundamental understanding is best understood by Turbo C. That's why I'm using Turbo C here. This is a simple example of C program to find average of 3 integers. This will demonstrate you the data type and type declarative instructions, input instructions, and output instructions. So you can ask me, we are not finding C in here. How you say that it is the input? Yes, you are right. We have two kinds of inputs, static input and dynamic. Static initialization of variables, dynamic initialization of variables. When we provide some value for a variable in the program itself, it is a static initialization. So if you read at runtime of the program, then it is dynamic initialization. Scene is used for dynamic initialization of variables. So I have not made use of scene here. I have only made use of static initialization. So there are 3 integer variables. Can you guess what would be the output? Can you guess? Guess the output. I hope everyone has guessed correctly the output as 2.33333. Am I right? Let us see now the output. We'll run and we'll see. Can you see the output? It is the compiler output, system's output. It's not my output. It's not my output. It is system's output. So how come it is 2? I'm just wondering how it is 2. Can anyone guess why it is 2? A very important truth about any programming language you have to understand here. In any programming language, not only C, C++, Java, in any programming language, when an integer divides another integer, the result is integer itself. Since the type of A, B, C is integer, the sum A plus B plus C is also integer. So 3 is also integer. Integer divides another integer, the result is integer. Integer by integer is integer. And that integer value is assigned to float. So what is the integer? It truncates the fractional part. When an integer divides another integer, it truncates because you are dividing an integer by another integer, the result is integer. The fractional part is truncated. This is called as a truncation. It is done automatically here. And the result is 2.33. 0.33 is truncated, only 2 is there. That 2 is assigned to average. And that you are displaying here. See how the average is. So to correct this, what you need to do, one of the operand you have to convert to float, real number. Either the numerator should be converted to float or the denominator should be converted to float. Say, let me try with simple. Since the denominator is a constant here, I can simply make it 3.0. Now it has become a real number. Now let us see. See, now the result is 2.33333. So we got the correct result because we made the denominator float. One of the operand must be float in order to get the result float. If both are integers, the result will be integer only. Now, if I ask you, no, don't make the denominator free, make the numerator float. Convert the numerator to float. Yeah, it is possible. But we cannot say A plus B plus C bracket 0.0. That is not possible. Mathematically, it is not possible. It is wrong. So how to convert this entire expression to a real value, real number? So this is done through typecasting. There is one concept in programming called typecast. What is typecasting? Basically, it is converting an expression to the desired type, converting the expression from one type to the other type. Now A plus B plus C is an integer. You can convert it to float through typecast. This operator is called as a typecast operator. Opening brace, closing brace, this operator is a typecast operator. In that one, you have to give float. See, this is what the numerator is being typecasted. Here, the expression A plus B plus C is converted to float. In this expression only, it will be done. Now let us see again, run. See, again, the result is correct. So if you convert either numerator or denominator to float, the result will be correct. Otherwise, it is not. Though it is so simple program, but one of the important truth is hidden here that you have to understand and remember. Now let's go to the next concept. So here we have seen how we output using cout, how we read. Now let us see processing instructions. Basically, we have seen that a declaration and simple input output. You are all familiar with this processing. Different kinds of processing is there in programming: arithmetic processing, relational processing, logical, bitwise, and then we assign values. So arithmetic processing uses arithmetic operators. All the arithmetic operators, including unary and binary. Unary, what are unary operators? We choose single operand, and binary operators, we choose two operands. Say plus 5 volts supply. I want plus 5 volts supply. So now plus 5, I'm saying plus 5. So plus is taking only one operand, 5. Now this is called as a unary plus. Minus 3.5 volts I want. So now minus is using only one operand, 3.5. So it is unary minus. Now we use increment operator, decrement operator. They are also unary operators. Then ones complement we use, that is unary operator. Logical not we use in C, that is also arithmetic unary operator, that is unary. It is of type logical and unary. So these were relational operators. Almost all relational operators are binary operators. Greater than, less than, greater than or equal to, less than or equal to, equal to. All these operators need two operands. That's why all relational operators are binary operators. In logical operators, we have logical and, logical or, logical not. Logical and logical or, they are binary, and logical not is a unary operator. And bitwise operator, one's complement, it is a unary. The remaining operators like bitwise bitwise or, bitwise and, bitwise XOR, left shift, right shift. These all operators are bitwise and they are all unary. And assignment, it is a binary because it needs both left hand side and right hand side operator. As per here, one of the important thing you need to know about the operators is precedence of operators. What is precedence of operators? If a set of operators are given in expression, what should be the order of their evaluation? The order of evaluation is called as hierarchy of operators or precedence of operators. How you will use it? You have seen in that average example. In the average example, so in this example, what's the need of putting the parenthesis here? So you have put A plus B plus C, and this you have put in bracket. Okay. If I remove the bracket, what is the problem? If I remove the bracket, what's the problem? Why bracket is a mandatory? Here comes the question of precedence of operators. You are given here two operators, plus and division. Among these, which will be the first one? How it will be there? What is the order of evaluation? If you don't give parenthesis, what is the order here? As per priority, multiplication and division enjoy higher priority than addition and subtraction. So first, C by 3.0 will be done. C is 2. 2 by 3.0, something like 0.666 will come over there. Then that you will be left with 2 plus operators, A plus B plus that result. So then addition will be there, A plus B will be there, and then that sum will be added to the result. So this is wrong. This is not the way of finding average. The algorithm for average is first find summation and then divide. So first we need to find summation. To find summation, first we have to add. Otherwise, if I don't put parenthesis, what happens? Division will come first. That's why what I am doing, I am making first addition. So parenthesis override precedence. Let the precedence be anything. First priority will be given to parenthesis, evaluation of parenthesis. And then the precedence work. So if you don't give parenthesis, precedence works. You have to take care how you want the expression to be evaluated. So the idea of precedence of operators is very important. So one clue I'll give you here. That clue is that all unary operators, there is no any exception. All unary operators enjoy highest priority. First priority will be for all unary. I'm not talking about parenthesis. Parenthesis will override. Forget it. That is not there in our discussion. If parentheses are not given and some set of operators are given, which operator will be evaluated? What is the order of evaluation? First, the unary set of unary operators will be evaluated, and then the binary operators will be there. So now you have an expression, say I plus 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 I. This way the increment operator you have used in C. I mean to say there is an expression which is with some set of unary operators. Then since all unary operators enjoy the same priority, same level, how they should be evaluated? What should be the order of evaluation? Should they be evaluated randomly? They should be picked randomly and evaluated? Or is there any, again, a rule? Can you tell me, is there any rule? Or random? Random or there is a rule? Just let me know. There is a rule, and that is called as association rule. That is, someone said precedence. Precedence, I told you that unary operators enjoy first, binary second, and precedence is clearly telling you use this and this. But when I have the same level, operators of the same precedence level, then how to resolve? Now both operators enjoy the same level of precedence. Then among the two, which one should be evaluated first? This is my question. For this, is there any rule or should it be random? So there is a rule for that. That rule is called, yes, someone said left to right, right to left. Yes, you are right. This rule is called as association. Yes, right. Association rule, associativity. This is called as a associativity. So what is that? For unary operators, the associativity is right to left. So you need to go from right to left for evaluating unary operators of same level. And for binary, the associativity is left to right. Say you have A plus B minus C. Now plus minus, they are of the same level. Then which one should be evaluated first, plus or minus? This will be governed by associativity. So for plus and minus, these are binary. The associativity is left to right. So first A plus B and then minus C. If it were a unary operator like this, plus A minus C. Now plus is a unary operator. So that is evaluated first, plus minus C. Minus is a binary, that is evaluated second. Now the question is, if you have only unary operators in the set, like plus A and logical not B, plus 5 or plus A, here I'll write see here, if you say like this, A plus A, logical, and I am using not B. Logical and is a binary, there is no question. It has the least priority. The first priority will be given to plus A, logical not B. Both are unary. So among these, which one will be evaluated first? Plus A or not B? So both are of the same level. Both are unary operators. Both are of the same level. So who will be evaluated first? Plus A or not B? So this is decided by associativity. When precedence of the same level we encounter, we go for the associativity. For the associativity for unary operators is right to left. So first logical NOT B is evaluated and then plus A is evaluated. Now you can see another example. One more set of operators is there which has right to left associativity. Now that I'll demonstrate you. Now see here, this look at this statement. Look at this statement. A equals B equals C equals 3. This is how we read. How assignment operator is there? 3 assignment operators. All 3 are same operators and same level. So which operator is evaluated first? A equal to B, B is assigned to A, is evaluated first, or 3 is assigned to C, C is assigned to B, B is assigned to A. This is evaluated. How it is? B is assigned to A and then C is assigned to B, then 3 is assigned to C. This is the one evaluation. The other evaluation is 3 is assigned to C, C is assigned to B, B is assigned to A. So one evaluation is going from left to right, the other is going from right to left. Yes, someone told it is a right to left. That is what you are right. You are right. Right to left. So unary operators have associativity right to left, and assignment also has a associativity right to left. I think you got the idea of associativity. So when we have operators of the same precedence level, the order of evaluation is controlled or governed by associativity. The unary operators and assignment operator has right to left associativity, and binary operators, all binary operators have left to right associativity. Okay, this is the very important as far as operators is concerned. So now let's see the next set of things. Control flow instructions. So the next category of instruction is a control flow. We control the flow of instruction, execution of instructions, flow of execution. We control flow of execution of instructions through these statements. That's why these are called control flow instructions. In this set, we have 2 broad categories: decision making instructions and repetitive tasks, for performing repetitive tasks. Let's see it. If else is a statement used to make a decision. You can decide, like using relational operators, logical operators, you use if else. Switch. When you have a multiple branching, lot of branching is required, that time you can make use of switch statement. And conditional operator is a ternary operator. Just now we discussed unary, binary. One operand taking one operand unary, 2 operands binary, and if it is 3 operands, it is a ternary operator. Conditional operator takes 3 operands. Say A equals 0 question mark, then print A is 0. Otherwise print non-zero. So this is how it is, taking 3 operators. Conditional operator is also used for decision making. It is more handy than if else. And while loop, do while, for what we have in C, the same thing we have. Anyone who is familiar with C, the same thing you can find in C++ also. We can see one example for all this kind of control statements. Examples of decision making. One example for decision making we'll see. have taken an example of point in a quadrant. If you enter any point, it should let you know in which quadrant it falls. Enter any point, some dimensions, some values, then see whether it is a first quadrant. You are deciding the quadrant number. So see, you are deciding, you are making a decision. How you are making a decision? Making use of if-else statement. How it should be used? Normally, if-else statement is used with relational operators and logical operators. You can make use of some arithmetic expression also. In C, C++ it works, but in Java it doesn't work, because in arithmetic expression gives you some value, some integer value, some real value. In Java, compulsorily mandatory it is to have an expression which should give you logical result, either true or false. So if I give here like this, someone says instead of x greater than 0, if you give like this is not a relational expression. Neither it is a relational expression nor it is a logical expression. So it is an arithmetic expression. You are assigning 0 to x. Here C or C++ compiler will not flag any error for you. It works. Why? In the beginning I told you, in C, C++, non-zero value is treated as true and 0 is treated as false. Now you are assigning 0 to x. So if 0 means what it is, if false. If false, the else part will be executed. If true, the if part will be executed. So even arithmetic expression is allowed, but it is not syntactically correct. Though syntactically it is correct, but it is logically not correct. Semantically it is incorrect. So you should take utmost care when you are giving expression in if. It should evaluate to either true or false. That sort of Boolean expression or logical expression. So I have made use of simple expression, relational expression greater than 0. So if x is greater than 0, that is true. It will come inside in the block. It will enter y greater than 0, first quadrant. If it is true, x is positive, y is positive. It means what? It is a first quadrant. We have entered the block. It means what? X is greater than 0 already. And we say we got y greater than 0 false. Means y is negative. So x is positive, y negative. Which quadrant it is? Fourth quadrant. So you have to say else fourth quadrant. If x greater than 0 is false, it means that x is negative. So if it is negative and we compare again, y is greater than 0. X is negative, y is positive. We say it is a second quadrant. Already x has become negative because we have come in the else part, means x is negative. Already x is negative and the condition y greater than 0 is false. It means y is also negative. X negative, y negative. What does it mean? It is third quadrant. This is how the logic is given here. Some one of you can ask me, why you have made it so complex? Why don't you say x greater than 0 logical and y greater than 0? Yes, you are right. But if there is a constraint like do not use logical operator, it's not available to you, say, that time this logic will work. Otherwise, you can make use of logical and you can make it simple. If x greater than 0, logical and y greater than 0, first quadrant. If x greater than 0 and y less than 0, this way you have to give 4 different conditions. I believe this is more simpler than that. So this is more simpler for compiler system, not for you, because there is less evaluation. Whereas if you make use of logical and operator, more evaluation will be there. Comparison as well as that ANDing job it has to do. Now you are not doing ANDing, so this is more faster than that ANDing logical. That way you can defend your program. So I guess you got it, how it is working. Let's run and see. So enter any point. Tell me some values. -4, x is negative, y is positive. X negative, y positive. I guess second quadrant it is. So you are right. So let's have one more run. Minus, we'll have x positive 5 minus 4. Fourth quadrant. Yes, we are right. The logic is perfect. Got it? How we use if else. Now let us see how switch we can use. Switch operator. This is also decision making. No, switch. You can have one look at it. If you use Linux, that time you have to say hash include IO stream only, and you have to add a statement like using namespace std. Here I have commented it because for DOS there is no any such requirement because we are not using standard C++. When you use standard C++ like GNU Linux, Ubuntu, if you are running in Ubuntu environment, that time you can say using namespace std because cout, cin are defined in a namespace called std. That's why you have to use with that standard GNU Linux. Now, so it is a DOS C++. You don't need that thing. That's why I have commented it. Now you can see one example for switch. It also works like your C switch only. There is no any difference. Switch, again the constraint is that the expression given in switch has to be of type integer. It should evaluate to a integer value. It should be an integer or character, but not evaluate to a real value. Switch, if expression evaluates to real, it will give you an error. It should be of, when you use an expression in switch, that has to be either integer or character. So in one statement we say it should be of type integral value. So again here default, if none of the case match, default will come into picture. Switch uses 4 keywords. Switch is a keyword, case is a keyword, break, default. Break, when that particular case matches and the execution is done, it breaks the switch, comes out of the switch statement. The same way it is like C only. You can just explore. Now let us see examples of repetitive task. Examples of loops. What the program is doing, can you guess? Look at the logic. Again, the syntax is similar to C. The C++ syntax is almost like C language because basically it is a C with classes. So the C syntax is used. Whatever syntax we have in C, the more or less the same syntax we find here. Yes, someone told it is a program to find sum of all numbers from 1 to n. All numbers from 1 to n. It's a repetitive. What is the repetitive task we are doing here? Repeatedly, what we are doing? Repeatedly, we are summing. We are adding the number. We are generating a new number, adding it. Generating a new number, adding it. Generating a new number, adding. How we generate a new number? By decrementing it. We started with n, so then the new number will be generated by decrementing it. So how long you will keep decrementing till it reaches to 0. And the condition is true, 0 greater than 0, the condition is false. As long as the condition is true, the loop keeps repeating. There are iterations. When the condition becomes false, while false, the loop breaks, the loop stops, and the control comes out of it. As long as the condition is true, it keeps repeating the job. Repeatedly it is performing. Sum is equal to sum plus n. So you can see here, enter value for n. Now, if I enter value for n as 10, we are all familiar. The sum of 1 to 10 is how much? So it is 55. So it is doing the summation is perfect. So one point you need to remember here in repetitive task is that whenever we try to use a loop, you must ensure that three things should be addressed properly. Three aspects must be addressed properly. One is initialization of a variable, then upgradation of the variable, updating the value of a variable, loop variable, and then setting the condition. So initialization sets the start point of the loop, upgradation sets steps of the loop, and condition sets what? Condition sets the end, where to end. It where to stop, that is given by the condition. So here the variable is initialized with the upper value n, say 10. I have given 10. 10 is the start value, initialized value. Start 10. Then 10 will be added to sum. Initially here, if you fetch the value of sum, it will be garbage value. That's why we must clear by initializing it to 0. Initialize it to 0 here. That will clear the garbage value, junk value, and 0 plus 10. That will be the new sum. New sum is 10. Then n will be 9. 9 greater than 0. True. Again enter. 9 plus old sum 10. 19. 8. This way it will continue till the value of n becomes 0. 0 greater than 0. False, we come out and we get. So remember to set the proper initial value. Properly it should update. If you say instead of n minus minus, if I make it n plus plus, what's wrong with this program? How it will behave? Come on, let me know how it will behave. You are moving away from the condition. The condition is what? N greater than 0. As long as n is greater than 0, we are saying. So you are moving. Yes, you are right. Infinite. Right. You are right. Komal, you are right. It is running infinitely. Indefinitely it will write. Because you are not coming towards the condition. You are moving away from the condition. When you move away from the condition, it leads to indefinite loop, infinite loop. Yes, you are right. That's why you should update the loop properly. It should move towards the condition. When you decrement, when you keep decrementing, it is moving towards 0. If you increment, it is moving away from 0. When it moves away from 0, the condition will never be false. So it will be always true. And this is how it leads to indefinite loop. Yes, you are all right. Infinite loop. Correct. You are guessing correctly. Let's take the next concept. This is very interesting concept in C++. Just have a look at the slide. I'll be back in few seconds. If you are new to C++, you will just wonder with this concept. Using this reference variable, we create alias names for variables. And this helps like anything to us in programming, especially when we define functions with pointers. So this will totally, through this concept, we can totally eliminate the use of pointer in our programs. How that we'll see. So basically, it is address of, it is not read as an address of now, it is read as a reference operator available in C++ for creating alias names. This is very good alternative available against use of pointers. We can avoid altogether pointers. The syntax of using it is, first you have to specify the data type of the variable, alias name, reference operator. So you can see here how it is. This int x equal to 5x is a variable already existing. For this x, you will create alias name a. This is the syntax for it. So if a is modified, x is modified. If x is modified, a is modified. We'll see one example of it. You can see this example. Same thing is there. X is an alias name for a. X is an alias name for a. If a is modified, x is also modified. Say I have incremented, modified a. So you will get the output as now what? A as 6 and x as not 5. X is also 6 because x is modified through a. Run it and see. See now, a is 6 and x is also 6. We'll find the use of this reference variable when we define functions. When we define functions and if more than one variable is getting modified in a function, if more than one variable is getting modified in the function, then normally we were passing addresses of those variables in C. Here you can avoid. Instead, what you can do, simply create an alias name for that variable, create an alias name for that variable and modify it. Just I'll demonstrate you here how we can do. See, I'll define one function now. Since it is of type reference, I use the data type as reference, modify. I'll take two variables, int x and y is equal to 7. Two different variables. I'll call the function here modify. I'll simply pass x and y and I'll display x and y here. So my modify function is modifying two variables and I'm successfully reflecting them back with the modified values. So I'm not passing addresses. You can see here. Look at this call. Look at this call. I'm not sending addresses. I'm sending just x and y. But I'm going to create alias names or reference variables for x and y. Modify int reference variable a. So now a is an alias name for x. Similarly, I'll create an alias name b for y. Now, if I modify A and B, automatically you are modifying X and Y, because A is alias name for X. A equal to 10 and say B equal to 20. So the modified values are 10 and 20. After calling modify, you will get the modified values. So simple. Earlier, what you were doing, you were passing addresses like this. You were passing address of X, address of Y, and then here pointers you were using. Here you were using pointer star. Now no need of passing address, simply pass the variable. Simply pass the variable like this. No need of address. Now let us run it and see. See, X is 10, Y is 20. So they got modified. We haven't sent addresses, and still we are able to reflect two variables from the function. Don't you think it is a wonderful concept? It has solved the problem of C programmers. So pointers is quite complex concept to use. Now with the help of reference variable, you can make it easy. Come on, how many of you liked it? Let me know this reference variable concept. Okay, thank you so much. Thank you for liking. It's a really good concept. You must know it thoroughly. I try to demonstrate it so that you can realize its potential use. Okay, now let's go for C++ functions. The difference between C functions and C++ function is important to note. You must note the difference. What is it? In C++, function prototyping is compulsory. You haven't used C compiler, pure C compiler. In C compiler, even if you don't provide a function declaration or prototype, it's okay. But in C++, it is a mandatory to provide a function prototype or function declaration. So what is it? What is the meaning of function declaration? Why we need it? It is just for the satisfaction of compiler. It is nothing to do with the logic of the program. It is nothing to do with the output of the program. It is just to satisfy the compiler. To satisfy the compiler, you must provide the function prototype. That is, you must declare the function. Declaring a function is called providing the function prototype. Function prototype, function declaration, they are one and same. Why we need it? Say someone knocks at your door and you open the door. Some strange person is there and he would like to give something to you, or he want to take something from you. Will you entertain him? Any idiot would entertain, but not we. Am I right? Okay. Before someone knocks the door, your friend has called you. So and so person with the so and so description, a person will reach to you. You give him this particular thing or receive this thing from him. Then if someone knocks the door and he says, I am so and so sent from so and so, you will receive or you will give whatever. You will entertain him. The second case, the latter case, you entertain. The former case, you didn't entertain. Why? In the former case, there was no introduction. In the later case, there was an introduction. The same thing happens with the compiler. If there is call to a function which is not been defined or declared, the compiler raises an issue. Like it says it must be declared or it must be defined. So if you define the function first and then you call it, no need of function declaration, because the function definition itself is an introduction to the compiler. that there is a function with this name, this argument list, this argument count. And then when you call, it will not raise any objection because you already defined. And then you are calling. So when you define the function before the call, there is no need of function declaration or function prototype. The need of function prototype or declaration comes when you call before the definition. See, in the reference variable example, what I did, first I typed the prototype, function declaration. I did this job. This is the job I did first. This is called as function declaration. Void modified. This line, this strip is function declaration or it's a prototype. What was the need of giving it? Why you gave it? Because when you don't give it and you are calling here modify x comma y and the definition is appearing after the call. So the definition is coming after the call. If you don't give this call is a strange call to the compiler. So that's why the compiler raises the issue. If you declare it, you have said to the compiler that in future I'll be defining a function with so and so argument, so and so name. So if there is a call, you just ignore it. So that's why this statement is there. This is made compulsory in C++. Function declaration, if you call a function before the definition. If you call a function after the definition, no need. If the definition is appearing first and then the call is there, no need of prototype. Now you can see here what I do now. I'll remove this. I'll remove this line. So I am not giving function declaration. It will raise a issue now. It will raise a issue. See here. See, the issue is function modify. See, this is function modify should have a prototype. This is the issue. So now for this, to remove this, what I did, I gave the prototype. But if I define it before the call, say I am defining after the call, I'll define it now before the call. So before the call means before main I'll define because I'm calling it in main. So I'll define it here. Okay. So now the definition is appearing before the call. The definition itself is an introduction to the compiler. So there is no need of prototype. There is no need of function declaration. So the compiler will not raise any objection now. See. Did you get my point? Did you get my point? Let me know. So, in a nutshell, if the call is appearing, okay, fine, great. Thank you. If the call is appearing after the definition, call is appearing after the definition. That means what? The definition is appearing first, then call. Definition first, then call, no prototype required. Call appearing first, then definition. Call first, later on definition, prototype is compulsory because the compiler is not knowing the call, what it is. That's why the declaration is must. In C++, function declaration is made mandatory whenever you define a function after the call. So this is one point you have to remember. Then the next point, this already you know, call by value. When we pass value of a variable, it is call by value. And call by passing address pointers we use, and call by reference I just demonstrated you the modify function. So limitation of call by value is what? Only one variable it can return. That's why we go for either pointers or a reference variable. So next concept in C++ function is very interesting. That we'll discuss, and then finally we'll wind up with function overloading. That will complete our language aspects. So in the next session tomorrow, we'll start classes and objects. How to define a class, how to create objects, how to pass objects to methods, how to return objects from methods, what are constructors, what is this pointer, what are static members, what are non-static members. This all we'll discuss in tomorrow's session. So today we'll wind up with function overloading. This is the last but one concept, inline functions, and then we'll wind up with function overloading. So what is inline function? What are inline functions? If you have done and if you are familiar with C macros, it is somewhat similar to a macro. So macro is what something defined like a function, hash define area 3.14 into r. You are passing some argument to area. So r is a radius. So you're defining hash define. That is a macro. What is macro? Macro is not a function. When you call a macro, that definition which you are given against the name simply will be pasted, will get expanded in the call. That is a macro. But since C++ is a better than C, function is better than macro in controlling the errors. This is advanced concept. Just remember, function is better than macro. How? Because when you define a function, you will list argument number, argument type. That way, at the time of compiling, the type checking will take place. So that's why in a function is preferred to a macro. But what is the functioning of a function? How it functions? How it works? Whenever you call a function, the control, the execution control, jump to the definition of function, does the job, and again comes back. If you have studied microprocessor, you may be remembering jump instruction. So when it jumps, before jumping, it saves the return address where to come back. Before jumping, it saves the arguments to stack. So this is the job it does in the background whenever there is a function call. Whenever there is a function call, it does this background job of saving the arguments to stack, saving the return address to the stack, and then jumps. And again, while coming back, it pops the return address and gets back the original copy of arguments. So in doing so, it spends some time. So function, whenever you define function, means you are ready to spend some time. What is the primary objective of defining function? You know, the primary objective is to save memory. Whenever something is getting repeatedly, we can write it as a function and call so that the memory is saved. So to save a large amount of memory, so to save more memory, some time you can spend, it is reasonable. That's why we define function. So if the function code is very small, like 1 or 2 lines of code is there and you are defining it as a function, hardly you are saving any memory here, but you are spending a lot of time. So you are making the process slower by defining it as a function. So I don't want this. I don't want it to happen. I want it to run faster, but still look like a function. And that solution is inline function. The body looks like a function, but the functioning, the working will not be like a function. The working like function, what? Control jumps. But when you define inline function and call, the control will not jump. The control will be there itself. Instead of jumping, what it does, it brings the code over there. The call gets expanded there itself with the definition. So for small, to save a very, very meager amount of memory, you should not spend more time. Let some memory be wasted, but the process be faster. If that kind of requirement is there, then you should go for inline functions. That is what you need to do trade-off here. You should not blindly define any function as inline. Where time is a crucial thing, not memory, use inline function. Where the code is very large and time is not a constraint for us, memory is a constraint, then define it as a normal function. And C++ cleverly does one job. Some idiot defines some function as a blindly, some function as inline. C++ compiler checks whether the function is worth to be defined as inline or not. If it is worth to define, then it considers it as inline. Otherwise, it discards that, rejects the request of inline. That's why inline is not a command to the compiler. It is just a request to the compiler. If anyone foolishly labels a function as inline, which is quite large function, then compiler cleverly rejects his request and makes it non-inline. Though in your code it is appearing inline, internally it will be converted to non-inline, which we are not aware of it. That's why what you should do, if it is a 1 or 2 lines of code, you should make it inline. Otherwise, you should not make it inline. And one more thing, the functions which return values, which use control statements like if, else, switch, loops should not be made as inline functions. Very simple code, like only just some assignment is there or some text displaying is there, you should go for inline. One example I have shown you here, inline white display, just such kind of thing you can make it. If you want more information about, you can explore on net, you will get an idea. But inline is just a request to the compiler, not a command. Remember this. Okay, shall we proceed now? We'll go to the next concept, function overloading, last concept, and very interesting concept. It is one type of a polymorphism, that is a static polymorphism. Since the binding takes place at compile time, it is called as static polymorphism. The only advantage is what? We'll not be defining different names for the same task. Say if you are performing addition of integers, addition of real numbers, concatenation of strings, then you will not give different names. If you are writing C functions, then you have to name them differently, because there is no concept like function overloading. In C++, you can use the same name. Say add. That is what function overloading. When you define more than one function with the same name, that is function overloading. The criteria for defining is what? The criteria, the criterion to overload the function. Blindly you cannot overload. There is some criteria you must satisfy. What is that criteria? There must be a mismatch in argument count or argument type. Then only the function overloading will take place. Without that, it is not possible. So we'll check this one. Internally what happens, even if you are used add, internally the compiler mangling, this is called as a function mangling. They change the names again. Internally they give different names. The compiler will give different names. It crushes the old name, whatever names you have given, and it uses new names. Mangling it is called. You can check on Google what is function mangling. You will get it is something related to function overloading in C++. So just do that. That's one assignment for you guys. Google function mangling, what is that, and see. So this is how the function overloading concept works. Basically, it is static polymorphism. Why it is polymorphism? One name, many forms. There is one name add, but there are different forms. One add for integer, one add for real numbers, one add for characters. This way, different forms. One name, many forms, polymorphism. Static polymorphism, the calls will be resolved. This is a call for this, this is a call for this. Call, function call, and their definitions are linked at the time of compilation itself, not runtime. Compilation time, the information is available. Why? How the information is available? Based on the argument count and argument type. This is the argument count, this call. This is the argument type. This is a call with these argument types. This is the function I am supposed to link. This is how the compiler uses this information and links the calls to function definitions at the time of compile. That's why they are called static binding, static polymorphism, static linking. So many names are there. Something static, not at runtime, at compile time. That is the meaning. Let us see some examples of overloading. Just you can see here, this is an example for function overloading. or define two functions with the same name. If it were a C program, you would have got error. How can you name two functions with same name? Since it is a C++, the concept is function overloading. It is allowed. Why it is allowed? There is a mismatch in argument count. I have created a mismatch in argument count. One function uses 3 arguments and there is another function which uses 2 arguments. So whenever there is a call with 3 arguments, it will be linked with a definition having 3 arguments. And whenever there is a call with 2 arguments, it will be linked with a definition which has 2 arguments. So this is how we will be able to implement static polymorphism. So integer sum is 20, real sum is 6.345 like this. So this is how function overloading concept is there. We find this function overloading concept in Java also. In most of the object-oriented programming languages, we have the concept of function overloading. Based on this same concept, we have constructor overloading also. In future, we'll learn. In our subsequent sessions, we'll discuss a constructor. What is a constructor? And we can see how a constructor can be overloaded. When we have multiple constructors for a class, it is constructor overloading. I'll demonstrate that part also. Now, I hope you enjoyed the session. Let me know how many of you have enjoyed and how you felt it. It's almost the time to wind up. It's 3:55 now. We'll wind up here and we'll meet for tomorrow's session. So the last 5 minutes I'll be using for your feedback, for your inputs. You just keep telling me how you felt the session. Any suggestions if you have, you can give it. Thank you so much. Thank you. Thank you, Shreya. Thank you for appreciation. Thank you. Thank you so much, Aditya. Thank you. Thank you very much. So thank you, Sachin. Thank you, Komal. Thank you, Aditi. Thank you. Thank you all. If you have any inputs, let me know. We'll incorporate in our future sessions. So let me know if you have any requirement, any kind of suggestion, inputs, feedback. Please let me know. I will try to incorporate in my future sessions. Thank you so much. Thank you. Thank you. Amit sir, can we stop here?
Yes, sir. Thank you,
Okay. Thank you, Amit. Thank you, Prashant. And thank you, ma'am. Thanks to one and all. I heartily thank all participants. I hope you enjoyed the session. And if you have any queries, any doubts, any inputs, please let me know. We'll try to incorporate in our future session. Thank you. Thank you so much.
And tomorrow we'll join same time.
Yes, same timing, 2 o'clock.
Tomorrow exactly we join at 2. Hello.
Yes, sir.
Prashant sir. उद्या आपण 2 वाजता start करू. Okay.
Yes.
Okay.
Yes. Okay.
Amit sir and Prashant sir, I'll take leave. Thank you so much.
Sir. Thank you, students. Thank you for joining with us.